Alright, this video is to help you understand what's called the Pythagorean theorem. The Pythagorean theorem is a way to find the third side of a triangle given the first two sides, as long as that triangle is a right triangle. The one thing required for the Pythagorean theorem is that it must work on right triangles. It can't just work on any triangle. So the Pythagorean theorem is given to you in the middle of the screen here. It's a squared plus b squared equals c squared. The hypotenuse is always the longest side. It's always the c in the formula a squared plus b squared equals c squared. So if we take that triangle that we have at the lower right here, 6 and 8 are the legs. They're going to be our A and our B. So in order to set this up, the first thing we're going to do is we're going to take a look at it. And we're going to say, well, this is therefore 6 squared plus 8 squared equal to c squared. If we take both of those numbers and square them, our legs squared added up though should equal our hypotenuse squared, which means 100 equals c squared, and if we square root both sides very quickly, we've got 10 equals c. And our third side of our triangle, our hypotenuse of our triangle, is 10. Now the one thing you want to be careful of is making sure you get that hypotenuse in the right spot in your formula. Note the two triangles on this screen. We know that one of the legs, 5 over here, is a leg. We don't know the second leg, or basically we can call that either A or B. So I'm going to call this one A. But I don't know A, I do know B then, my other leg of my triangle, and I know my hypotenuse. So I can still set up my formula saying that A squared plus 5 squared, my other leg, equals 6 squared, the hypotenuse squared. In that case, with a little bit of quick algebra, A squared equals, we're going to take our 36 over here at the right, we're going to subtract off our 25 from the left, a squared equals 11. Well, unfortunately, the square root of 11 is not a pretty number, but that just means that we would have to go to our calculator. It doesn't make a perfect Pythagorean theorem, but a could still equal 3.317 approximately, rounded off to 3 decimal places. So there's our number there. Now, go ahead and try the triangle over here at the right, and in just a second I'll put the answer up on the screen. It's a similar situation. Again, you know a leg, you know the hypotenuse. See if you can find that third side. Alright, solving it away. Again, our leg was 12, our hypotenuse was 13, which means that 13 squared is 169. I'm going to take that 12 squared, or 144, and subtract it over to the right side. So 169 minus 144 was 25, but don't forget that's equal to b squared. Therefore b squared, I need to take the square root, take the square root on the right side, and again, no need for a plus or minus. We're talking sides of a triangle, so we can just say positive 5 would be the third side of that triangle. Because that came up as a nice clean number as opposed to the 3.317 we got in the previous problem, we would say that this triangle at the right is a Pythagorean triple. It's 3 whole numbers that make up good sides for a right triangle. Okay? They fit into the Pythagorean theorem, again, with 3 whole numbers, no square root, leaving us with a decimal value, an irrational number. So, another way we can use the Pythagorean theorem is actually to work it backwards. If you have 3 sides of a triangle, such as 2, 8, and 4, you can plug those into the Pythagorean theorem. Remember that the hypotenuse is always the longest side, so I need to put my 8 in on that right side. And if 2 squared plus 4 squared happened to equal 8 squared, notice here it does not, but if it did, then this would have been a right triangle. Well, because 2 squared plus 4 squared does not equal, what I can tell us is 2, 4, and 8 cannot form a right triangle. 9, 12, and 15 on the other hand, again 15 is the largest side, so let's plug that in as the hypotenuse. And they both come out to 225. 9 squared plus 12 squared is 225. 15 squared is 225. Which just tells us, again, that 9, 12, and 15 form a right triangle. Kind of a nice way to use that Pythagorean theorem. I hope that helps you with the Pythagorean theorem. If you have any questions, make sure you talk to your teacher. Otherwise, good luck, and as always, have fun.